Hello everyone. In the previous classes, we had completed a question number till 3 along with all theme explanations. Today, I am going to start from the question number 4th. And the question number 4th, it is all figure is already given in the book, and the angles are also mentioned. And what we have to find, we have to find the value of the BDC. This BDC angles really we have to find. It is given the question angle ABC is 69 degree and angle ACB is 35 degree. These two angles are mentioned in the question and we have to find the value of BDC. So in previous classes I explained the angle in the same segment theorems. We'll use the angle in the same segment theorem and we'll solve these questions. So I hope you had gone through the theorems. If you had not gone through the theorems, you please refer the theorems. Without the theorem, you will not be able to understand this question. So the theorems is more important. Now, what we will do, you can see angle ABC. This complete B is 69 given the question. ACB is 31 given the question. So with the help of the angle sum property ABC, we can easily find the value of A. We can easily find the value of A. So we can write in the triangle ABC. In triangle ABC, the three angles sum BAC is angle A, ABC and ACB is equal to 180 degree, and the BAC is 69 and this is the 31 equal to 180 degree. 69 plus 31 100 is equal to how much? BAC. So now this 100 will transfer the side. So BAC will be 180 minus 100 degree is equal to 80 degree. Now this BAC, the BAC and BDC, they are both equal and they will be equal to 80 degree. Now you may be thinking why they are equal. So by using the theorem angle in the same segment, I told in the previous class BC is the segment and the A and the D is formed on the circumference of the circle. I told that segment means the angle formed with the chord and with chord and the angle should be on the circumference of circle. To understand this property, I told that you have to see the two things common. BC is common and A and D is the common forming on the circle. So you can write here angle in the same segment are equal. Are equal. This is the theorem 10.9. So this we are supposed to find BDC. I got the value of BDC. This complete the questions. The question number 4 is completed. I hope you understood the question number 4. Now you see the question number 5th. So BDC is the 80 degree we are supposed to find. Now you see the next question. So next question, this is the 5th question. You can see, and here the figure is already I had made beforehand. Now in this question we have to find the value of the ECD. We have to find the value of BAC. BAC. So BAC value we have to find, and the two values are given. And this angle BEC or CEB. This angle E is 130. Here it is 20, and we have to find the value of A. So what I am going to do? This is 130 and this is making linear pair. So I will find the angle here. Then with the angle sum property I will find the value of D, and the D will be equal to A because the angle in the same segments are equal. So this questions get completed. So this BEC, and I am writing here angle 1. Angle 1, and this is the angle 2. This is at D it is the 2. Otherwise, you can write a name also. If you do not write the angle 1 and 2. So this BEC plus DEC. DEC. This is forming linear pair. DEC is 180 degree. This is the linear pair. DE, this angle is the E. Here 130, BEC plus DEC is forming linear pair. So this BEC given 130. So we can find a value of DEC. So DEC will be equal to 180 minus 130 is equal to 50 degree. So I got a value of DEC. Now this D at the D, I am writing the angle 1. Angle 1. Now these three angles we have. DEC I got 50. Angle 1. Angle C is given. So easily I can find the 1. Or if you don't want to write the 1, you can remove. You can write the name EDC. Okay. So in triangle EDC. Now the three angles are the E, D and C. So the name of the E is DEC. The name of C is the ECD. The name of the D is EDC. All are 180 degree. And this DEC I got 50. ECD I got 20. And D I don't know. 70. So EDC is how much? 110 degree. 110 is the EDC angle. Now, but I have to find the value of the IR. I had already explained in the chapter number 6th and 7th. If this EDC, this angle is formed at the E. If we increase the arm E to B, the angle will be D only and it will be 110 only. So you write EDC or BDC. They both will be equal to each other because the angle is formed at the D. So you can write here the EDC and BDC equal to 110 because they both are equal to each other. EDC and BDC are 110 because this the angle is formed at the D and E we extend arms only. Now this BDC and BAC, they both are equal and this is equal to 110. Now I have already divided both are equal. BC is the common part and D and A are the angle formed on the circle. So we have a property theorem, the angle in the same segments are equal. We can write angle in the same segment. This is theorem 10.9. And in the same segment are equal. So I hope you understood this question. How to solve the. Now we take the question number 6. Now question number 6. In question number 6, the figure is not given. We have to meet the figure. So it is said that ABC is a cyclic quadrature, and I told that what is a cyclic quadrature? The quadrature whose vertex lies on the circumference of the circle or on the circle, it is called cyclic quadrature. So we have to make one cyclic quadrature. Then it is said that a diagonal intersect at point E. So according to the question, there is ABC is a cyclic quadrature whose diagonal intersect at point E. So we have to make two diagonals and it is intersecting at point E. And DBC is 70 degree and BAC is the 30 degree. We have to find the value of BCD, and if AB is equal to BC, find the value of ECD. This we are supposed to solve. So this is the question number 6th. You have to draw one cycle with the help of compass and protractor. With the help of protractor, then after that it is said that this is the two AB is the quadrature one quadrature which is forming the arms at the cyclic quadrature. So this point is the D, this point is A, B, C, D. Now it diagonals of the figure intersect at which point E. And now this angle form BAC, it is how much? 30 degree. The BAC is 30 degrees, mentioned the question, 30 degree is the angle here. And angle DBC is 70 degree. Now we have to find, and it is given that we have to find the value BCD value we have to find. So in given part, the two angles are given, along with that AB is equal to BC is given. AB equal to BC is given in the question, and we have to find the values of two angles. First one BCD, then ECD. So BCD and ECD angles we have to find. So for this again we have to use the theorems. So what we will do first, you can see here this B is formed up to here. It is not a complete B. First this should be clear. And here the angle A is 30 degree. So BAC and BDC, now we will use one theorem. The same theorem that just now we had used. This BAC and BDC, they both are equal and they will be equal to how much? 30 degree. Because BAC is given 30, so BDC will be also 30. This by the theorem, angle in the same segment. Angle in the same segment are equal. So this will be also how much? 30 degree. This Y segment it came 30. Now we take the triangle BCD. So we have the D angle, we have the B angle. Easily we can find the C. So in triangle BCD, the BDC, DBC and BCD, all three angles is how much? 180 degree. Now D is how much? 70. B is how much? D is 30. B is 70. So BCD will be equal to 180 degree. 70 plus 30, 100. And 100 plus BCD 180. BCD will be equal to 180 minus 100, 80 degree. 80 degree, we got one answer. BCD is 80 degree. Now we have to find the value of ECD. This is a little complicated because ECD is this one small angles. So what we will do, we had one proper side given, AB equal to BC. This is the vertical triangle ABC. So in triangle ABC, two sides are given, AB and BC are equal. So if this we study one theorem, if the sides are equal, the angle opposite equal sides are equal. So if this will be 30, this will also be the 30. So we write here in triangle ABC. In triangle ABC, AB is equal to BC. It is mentioned in the question. So we study one theorem. If the sides are equal, the angles will be equal. So this if the BAC will be equal to BCA, BAC is equal to BCA, and it they both will be equal to how much? 30 degree. And here you will write the angle opposite equal sides are equal. Angle opposite to equal sides are equal. So this angle I got 30. Now complete C is how much? 80. Because BCD full C is the 80, and this I got 30. Now easily I can find a value of ECD. So 80 minus 30. I hope it is clear, because this BCD full C is 30 degree, and I got the value of BCA how much? 30. So I can find 80 minus 30 how much? 50 is the answer. So we can write this steps here. So this will be, now we have to find our ECD. So I am writing here BECD ECD will be equal to BCD, full BCD, complete BCD angle, C angle, minus EC BCA. So 80 minus 30, ECD will be how much? 50 degree is the answer. So ECD we got 50 degree. ECD got 50. This completed question number 6th. Now we have to solve the question number 7th. It's over. This is a little tough question. You need one practice for this question to solve. Now question number 7. It says that if the diagonals of the cyclic quadrilateral are diameter of the circle, means so what we have to do, we have to make one cyclic quadrilateral. Question number, if diagonals of the cyclic quadrilateral are diameter, means we have to make one cyclic quadrilateral, and diagonals of this quadrilateral will be the diameter of the circle. It will become diameter of the circle. Through the vertex of the quadrilaterals, prove that it is a rectangle. We have to prove that figure is a rectangle. So we will make one figure 7. Question. This is the cyclic quadrilateral. His name is the ABCD. The cyclic quadrilateral, because its vertex should be on the circle. So this is the cyclic quadrilateral, and it is said that diagonals are the diameters. So we will draw this diagonals, and the diagonals always pass from the center of the circle. So we can write here this is the O. Similarly, another diagonal is the BD, is also passed from center of circle. So this diagonals are the diameters. Means BD is the diagonal for the triangle quadrilateral ABCD, but it will be along with the diagonal. It is the diameter also of the circle. Diameter means the diameter of the circle. So that now we have to prove that this is a rectangle. So to prove ABCD is quadrilateral ABCD is a rectangle, and you know how to prove that. What we are supposed to prove in rectangle? To prove rectangle, we have to prove that all angles should be 90 degree. And to prove that all angle 90 degree, we'll use the theorem angle in the semicircle. And I told what is the angle in the semicircle. The angle in the semicircle means there should be one circle and there should be one diameter. The angle subtended by the diameter will be called the angle in the semicircle. I hope you remember this one. This is the diameter, and the angle formed here will be the 90 degree. This is called angle in the semicircle. Similarly, angle from here will be also the 90 because this is also the angle formed with the along with the diameter. Diameter and this angle will be the, so AB will be the diameter and the C, at C it will form the 90 degree and AB diameter BD will be the 90 degree. This is called angle in the semicircle. This I already explained you in the previous class. So if in we will take one, now you can see this one. If AC is the diameter, if AC is the diameter of the circle, then angle ABC, if the AC is the diameter, so which two angles will be 90 degree? B and D. ABC is equal to 90 degree and ADB will be also, ADC will be also 90 degree. ABC here will go for 90, here will go for 90 because AC is the diameter, then the angle in the semicircle will be 90 degree. So if you have to understand, you can do in this way also. Draw one quadrilateral, make it cyclic. Then you can draw the AC here. This is the AC. At this point is the D, and this point is the B. So I already told if the diameter is there, this angle will be how much? 90. The angle in the semicircle, and this angle will be also 90. The angle in the semicircle. Similarly, so I got these two answers. I got ADC 90 and ABC 90. Now, if I have, so I got these two angles. Now, if BD is the diameter, BD is the diameter, then what we have to do? We will draw the BD. So now BD is diameter, which will be the semicircle angle C and A. So what is the name of C? BCD 90 and BAD 90. Now you can see that all angles we got 90 degree. If all angles are 90, I hope you understood this axiom, and here you have tried everywhere the angle in the semicircle is right angle. Here also same statement, the angle in the semicircle, angle in the same statement, you have tried angle in the semicircle, right angle. Now all four angles are 90. Therefore ABCD is a quadrilateral, ABCD is a rectangle. So this is the solution of the 7th question. Now 8th question. Eighth question. If the non-parallel trapezium are equal, prove that it is cyclic. Means we have to make one trapezium, and that trapezium should be cyclic. ABCD is a cyclic trapezium. Now this trapezium, we know that DC is parallel to AB and it is given, it should be always, you should all know this property. In the trapezium, once pair is parallel, AB, DC will be parallel to AB, and it is also given non-parallel side. AD and BC are non-parallel side. AD and BC are non-parallel side, and they are equal to each other. AD is equal to BC. This is a property of trapezium. It's there is one pair is parallel. So AB is parallel to DC and AD will be equal to BC, non-parallel side. This is the AD and BC are non-parallel side. In the question it is given that non-parallel sides are equal. This is the AD is equal to BC. So AD is equal to BC, non-parallel sides are given equal. Now we have to prove that it is cyclic quadrilateral. To prove cyclic quadrilateral, I already told what to do. To prove cyclic quadrilateral, we have to prove that opposite angle, angle A plus angle C, 180 degree, or B plus D, or either you can prove this one or B plus D or 180 degree. Then it will call the, if this opposite angle is 180 degree, then we can say that ABCD is a cyclic quadrilateral. If this be proved. So for that what we'll draw? We'll draw perpendicular. Here it will be M, here it will be N, this will be 90 degree, this is also 90 degree. So we will draw, write in construction, draw DN perpendicular to AB, CN perpendicular to AB. Now we'll take this two triangle ADM and C, B and C in triangle ADM, BCN. Now this two triangle we have to take. Now in the triangle it is given that AD is equal to what? BC, given. DM equal to what? CN. For this what you will write reason? DM equal to CN, you will write here distance between the parallel sides are equal. Distance between parallel sides are equal, and M and N are 90 degrees. You can write here AMA and BNC, each 90. Now these two triangles will be congruent. Now this is the right angle. This AD will be the hypotenuse side, and so we by RHS criteria. If these two triangles are congruent, so we can write that angle A is equal to angle B. Angle A plus angle B. Angle A is equal to angle B, CP. Yes, angle A plus angle B is equal to CP, CD. Because two triangles are congruent, then their angles and sides will be also equal. Now this A is equal to B. So now in the trapezium AB is parallel to DC. If the AB is parallel to DC, that means A and D are the co-interior angles, and B and C are also the co-interior angles. And one more property that trapezium has, the adjacent angles of the parallel trapeziums are supplementary. So this A and D will be also supplementary, and B and C will be also supplementary angles. So either you can use the co-interior angle property, then we can write A plus D equal to 180. The interior angle on the same side of the transversal are supplementary. BC is parallel to AB, and this A and D are the co-interior angles. So we can write here angle A plus angle D equal to 180 degree. You can write here co-interior angles or adjacent angle are the supplementary. Co-interior angles or adjacent angles of any reason one. Now A plus D equal to how much? 180 degree. Now you have to see this one. A plus D equal to 180 degree. But A is equal to B. So in place of D, can we write the B? A plus D is equal to 180 degree, and we have to prove that A plus C is the. So now A and B both are equal. So we can do one thing. If A and B are equal, in place of A we can write B. In place of A we can write B, and the B plus D is equal to how much? 180 degree. Now B plus D equal to 180 degree because A and B both are equal to each other. Now B and D is 180 degree. We have to prove this one. Angle B plus angle D is 180 degree. Either one A plus D or either B plus D. Then we can call it as a cyclic quadrature. Therefore, we can say that's it. Similarly, we can prove. A plus C is also 180 degree. Therefore, ABCD is a cyclic quadrature. ABCD is a cyclic quadrature. ABCD is a cyclic quadrature. At last you can write ABCD is a cyclic quadrature. This is the proof of the question number 8. Now, next question you see. Now, 9th and 11th will be the homework, and so we will solve the remaining two exercise questions. That is the 10th and 12th. Question number 10th, 9th and 11th is the homework. 9th figure is given. You have to use one theorem and solve this question. So that 10th question. Now we will understand what is the fact in the question. It is said that because this question figure is not given, so I thought to explain this question. If the circles are drawn, means we have to draw two circles, and taking the two sides of triangle. There is one triangle. The one side with the one side we will draw one circle. With other side we will draw the other circle, and that side will become the diameter of the circle. Means there is one triangle. Suppose I am making this to understand. This one triangle ABC. With AB you have to draw one circle, taking other side. So this will become what? Diameter of the circle. And the AC you have to draw other circle. This becomes the diameter of the circle. Means the triangles. One triangle, one sides will become the diameter of the one circle, other side of the triangle become the diameter of other circle. Then we have to prove that intersection, where these two sides intersect, that intersection of this circle are on the third side. Means these two circles are intersecting at the third side of the triangle. So I have taken this one. AD is the side of the triangle, and with the AD I had drawn with the diameter. So AD is the diameter of the circle and AC is the diameter of the circle. Now we have to prove that where they are intersecting, this will be the third side of the circle. So this we have to prove that they are intersecting at the third side of the circle. So to prove that, we have to prove that this they intersect at the third side of the circle. That means B, D, C, they all lie on the one line. This we have to prove. So we have to prove that the BDC line on the point of intersection of this circle lies points that B lie on the BC. BDC lie on the one line. B lie on the sides. To prove B lie on the sides. So that for that we will use one theorem. Join you can write join A to B. I had written with the dotted line join A to B. Now angle ABD, if AD is the diameter, then angle ABD is how much? 90. Angle in the semicircle. Is right angle. And similarly, if AC is the diameter, then angle ABC will be how much? 90 degree. Same reason, angle in the semicircle. And I have already told this. Now you add both ABD plus ABC. So 90 plus 90 equal to how much? 180. Now if this is 180 degree angle, that means it is a straight line. Now 180 degree angles come when there is the straight line. So now I thought this is a 180 degree angle. Therefore, I can say that DBC is a one line. DBC is one line, and B lies on DC. B lies on DC. So this is the proof of the question number 10. Now question number 12. Over. This question is over. Now next question, last question. Along with the last question, we'll complete the chapter also. Now it is said that to prove that there is cyclic parallelogram, we have to take one figure and make it cyclic curve. This ABCD is a parallelogram. You can write here in given part you can write given ABCD is a cyclic parallelogram. Cyclic parallelogram means what? It is the cyclic also. Along with the cyclic, it is the parallelogram also. Parallelogram means what? Which opposite sides and which opposite angles are equal to each other. It given cyclic parallelogram, and to prove it is rectangle, prove that AB quadrilateral ABCD is a rectangle, and to prove rectangle we have to make all angle 90 degree. Just now we have solved one question. So now this ABCD is a cyclic. That means angle A plus angle C will be 180 degree, and angle B plus angle D will be 180 degree. This is the property of the cyclic quadrilateral. Then the opposite angle will be also equal. A is equal to C, B is equal to D, because the opposite angles of the parallelograms are equal. So solution part, angle A plus angle B is angle A plus angle C equal to 180 degree, because cyclic quadrilateral. You can write cyclic quadrilateral. Now A plus C is a cyclic quadrilateral. Now angle A is equal to angle C, because opposite angle of parallelogram are equal. In place of C we can write A, and here you can write angle A is equal to angle C. Opposite angle of parallelograms are equal, or property of the parallelogram. Now 2 times angle A will be how much? 180. Angle A will be how much? 90. If A is 90, C will be also 90. Therefore, C is also 90. Now similarly we can write B plus 40. B plus D is equal to how much? 180, cyclic quadrilateral. Now, but B is equal to D. So in place of D you can write the B, because opposite angle of parallelogram are equal. Property of parallelogram. 2 times angle B will be 180. Angle B will be 2 times angle B will be 90. The B plus D will be 180, cyclic quadrilateral. Cyclic quadrilateral. Angle B plus angle B will be 180 degree. 2 times angle will be 180 degree. Angle B equal to 90. Now B is 90, therefore D will be also 90, because it is a cyclic. Both angles are equal. Now we can say that all angles are equal 90 degree. Therefore ABCD is a rectangle, because all angles are equal. And we can write that quadrilateral ABCD is a rectangle. All angles are equal, all opposite sides are already equal, given equal because it's a parallelogram. Opposite sides are equal, opposite angles are equal. So this along with the question number 12, we completed the 10 chapters. Now 3 chapters left: circles, quadrilateral, and the surface area and volumes. So this chapter is completed. You can revise this chapter at home. In the next class we will start the new chapters, and we'll try to complete the chapter also as soon as possible. And now this video is little 45 minutes, because if you have the content, you can practice at home, and all chapter will be coming in the final examination. There is not any cutoff. Only the deleted part will not be the part of the examination. I hope you are practicing mathematics daily at home. Till then, goodbye. Have a nice day.